All right, in this video, we want to solve these integrals using substitution, and these are slightly more difficult questions, not too difficult, but not the basic ones either. So let's get into it. In this first question, we have two functions and they're both linear. Now, normally we have like a quadratic that if you derive turns into a linear. So you know to pick u as the quadratic function, but when they're both linear, generally speaking, you want to pick whatever's inside a square root because that's a bit more complicated as your u. Then we're going to derive this function. And then we're going to just isolate the dx. So I'll cross multiply the 2 to the bottom. And now we want to do our substitution. Problem here is when I do my substitutions, I'll show it in this next step. I still have an x in my equation. I need to get rid of this x, and that's what makes this question a little bit more complicated. But it's not too bad because I know that I can get rid of the x by just isolating x over here in terms of u. I'll just start by subtracting 1. And then I'll just divide by 2. So I can now replace this x with u minus 1 over 2. I'll rewrite this as u to the power of half, so it's easier to simplify. Then I just have du over 2. So now I can just simplify this whole equation here before integrating it. U times u to the half is just u to the 3 over 2. Negative 1 times u to the half is negative u1 over 2. And 2 times 2, that's just 4. We can either write it on the bottom, or you can write it at the front as 1 over 4 as well. Makes it a bit easier. Since it's a constant, you can put it in front of the integral. And then we can just need to integrate the top over here. So I'll actually do that in this step itself. I don't want to rewrite it. I'm going to write that as 1 over 4 in the front over there. Let's integrate this function next. So the integral of u to the 3 over 2, just adding 1 to the exponent. So that's u to the 5 over 2 divided by 5 over 2. And this is just u to the 3 over 2 divided by 3 over 2 and plus c. Now all we have to do is simplify this. 4 times 5 over 2. Well, 1 times that is just the same thing. 4 times 5 over 2, that's 20 over 2, which is just 10. And 4 times 3 over 2, that's 12 over 2, which is just 6. And that's the integration right over there. And then last step is just replacing the u's back with 2x plus 1. And that's my final solution for that first question. Let's take a look at the second question over here. Usually you pick u as the higher exponent because if you derive it, you'll get the smaller one, but the higher exponent is by itself over here. I'm going to show you what happens if we do that, but it's not the right step in this question. So if I substitute this all in over here now, if I substitute this dx in over here, I'll have du over 3x squared. This will be replaced by u, but it's impossible to simplify this. So I can't really isolate x squared in this equation. It's a bit difficult. So we know this substitution is wrong over here. Generally speaking, u is usually whatever's inside the square root. So u equals x squared plus 1, du over dx equals 2x, du over 2x equals dx. Let's do our substitution now. So x cubed, I can't really change. X squared plus 1 is u. and dx is du over 2x. This x and cube can cancel out here. That becomes a square. And then I still have an x square here that I need to get rid of. I see I have an x square here. I can isolate that by just doing u minus 1 equals x squared. So I can replace the x square over here with u minus 1. And I'll just write this as u to the half instead, and du over 2. Now we just have to simplify and integrate this. I'm just going to write the 1 over 2 at the front. And then over here, I'm multiplying u times u to the half is u to the 3 over 2. Negative 1 times u to the half is u to the half. Now all I have to do is integrate this. That's just u to the 5 over 2 divided by 5 over 2 minus u to the 3 over 2 divided by 3 over 2 plus c. Just have to simplify by multiplying this 2 over there. So I will have u to the 2 times 5 over 2 is just 5. It's just 3. Then last step, replacing my u's back with x squared plus 1. Now let's go to the third and final example over here. This one is pretty similar. Again, normally you're thinking you might pick x squared plus 1 as u, but the problem is the exact same one as the last question where we can't get rid of the x. I'm not going to waste my time doing that. Instead, I'm going to just straight away go with whatever's inside the square root. So u equals x minus 2, du over dx equals 1, and then du over 1, which is basically du equals dx. Let's do a substitution next. Nothing can cancel over here. I still need to get rid of this x square here. I need to turn this into an x. I need to get this into an x squared somehow. So I'm going to add 2 to the other side. And then I'm just going to square both sides over here so that I can turn this into an x squared. So now instead I can substitute this as u plus 2 square plus 1 times, I'll change this to the u to the half du. So now I just have to integrate this. Before I integrate it, I want to simplify it. I'm just going to expand that bracket. So that's u squared plus 4u plus 4 plus 1 u to the half du. And I'll combine like terms inside this bracket. So u squared plus 4u plus 5 times u to the half du, and then I'll multiply this u to the half into the bracket. That's just going to be u 5 over 2 if I add the exponents, plus 4u 3 over 2, plus 5u 1 over 2 du. Now I can integrate this. I'll have u to the 7 over 2 over 7 over 2 plus 4u to the 5 over 2 over 5 over 2 plus 5u to the 3 over 2 over 3 over 2 plus c. Just have to simplify the constants. There's nothing to simplify there. Just going to flip that. So 2u 7 over 2 over 7. Over here, it's going to be 8 over 5 because I got to multiply that 2 with that 4. 8u 5 over 2 over 5. And this last one here, 2 times 5 is 10. So 10u 3 over 2 over 3 plus c. And finally, just replacing the u's back with x minus 2 as my last step. Oops. And that is my final solution to this question. If you made it to the end of this video and you found this content helpful, please hit that like and subscribe button. Thank you for watching and have a wonderful day.